All right, welcome to another rendition of Math is Easy Step by Step. Here in this video, I'd like to go over more examples of exponents with the power to a power rule. Here in example number 3, you're going to see 3x inside parentheses raised to the power of 3. So we have a power to the power. Now, the rule was you could multiply these exponents and you'd have 3x to the third power. However, be careful, be careful, be careful. This 3 has an invisible 1 in the exponent's place as well. And I'll show you that in an attempt to show you there's multiple ways to answer these particular type of problems. Not just one way, but there's multiple ways. So understand this 3x raised to the third power means 3x times 3x times 3x, or this term times itself 3 times. Let's take a look at what that looks like here. Just like you see here. 3x to the first power times 3x to the first power times 3x to the first power. So simply, when you write this out, we're going to multiply like terms. So 3 times 3 times 3. X times x times x. And remember, when you multiply and you have a base, here x, you're going to add these invisible ones. So remember, show these invisible ones. It will help you dramatically. So in this next step, I'm kind of showing you that here. And I'm going to actually solve this problem in a different way, showing you some more invisible ones. But we have here again 3 times 3 times 3 times x times x times x. Okay, this is kind of like an expanded form, which I've talked about in other videos. So what is 3 times 3 times 3? It's 27. Times 1 times 1 times 1 is 27. And remember, this x is attached through multiplication, so you can't separate the two. The terms are attached at the hip, so to speak. And what's 1 times 1 times 1? Well, that's that x here. 27 times 1 is 27x. You add these exponents. Remember, show your invisible ones. There's an invisible 1 in this exponent's place attached to the x. So 1 plus 1 plus 1 is 3. So the answer here is 27 x to the third power. Let's take a look at the same problem, but solved in a little bit different of a way. So as you can see here, it's the same problem, 3x raised to the power of a 3. But now I'm showing you the invisible 1 that's attached to this coefficient, 3, and the variable x. I showed you this invisible 1 earlier with the x value. Now I'm showing you that invisible 1 with the 3. By showing these invisible ones and knowing where they're at, it really, really, really clarifies a lot of things in mathematics, and it eliminates so much of the confusion when performing mathematics. So let's go ahead and move this further. Now remember, again, you can multiply the power to a power. That's a power of 1 raised to a power of 3. So a power raised to a power. The rule is you can multiply these power to a power. So 1 times 3 is 3. 1 times 3 is 3. Let's take a look and see what that looks like here. So I'm showing you this here. That was the invisible one here. You can write a whole one. You don't have to do invisible. I do invisible ... to show you as a teacher, hey, that's an invisible one. But you can write a 1 right there. It's totally legit. Again, I do the .111 to show it's invisible as an instructional tool. But you can write 1 right here. It all means the exact same thing. So again, 1 times 3, 1 times 3. I'm showing you that here. 1 times 3 is 3. 1 times 3 is 3, and 3 times the invisible 1 in front of that x is 3x. Okay, we're going to move that a little bit further along here. Let's show you these final steps. So again, 3 to the third power is 3 times itself 3 times. These two terms, the terms are attached to the hip through multiplication. So I'm going to show them times x times x times x. When we multiply, we add those Exponential values, 3 times 3 times 3 is 27, times 1 times 1 times 1 is the 27x. We add those values to get 27x to the third power. All right, let's take a look at this example here. Now, there's a lot of stuff going on here, so I don't want to confuse anyone. Now, again, I want to show you multiple ways to answer this particular example number 4. There's not just one way to solve many, many problems in mathematics. There are more than one way, and I'll show you again another method you can use to come up with the same answer. So in this example 4, we've got inside the parentheses x squared and times y cubed times z to the fourth raised to a power, so power to a power of 2. All right. So what does that mean? That means this whole term inside here times itself twice. And that's what I'm showing you in this next step. X squared times y cubed times z to the fourth, parentheses. Next to parentheses means multiply times x squared y to the third, z to the fourth. And I'm just going to write that out by separating the terms with a dot, which means multiplication, decimal. Excuse me, a dot for multiplication. X squared times x squared. I'm going to put these like terms together and using multiplications. Times y cubed times y cubed times y cubed times y cubed times z to the fourth times z to the fourth. Okay. Remember, there's an invisible 1 in front of all of these terms. And so we got 1 times 1 is x. Add those two, x to the fourth. That's what I'm showing you here. Times y to the cube times y to the cubed. Add those exponents. 1y times 1y is y to the sixth power there. Adding those exponents. 1z times 1z is 1z. Adding those exponents is to the 8th power. So simplified, this is x to the 4th, y to the 6th, z to the 8th power. So I wanted to show you a different version of this type of problem. So remember, power to power means, hey, we can just straight up multiply these guys, right? We can just multiply these terms. And that's what I'm showing you here in the second method of solving this particular type of problem. Okay, so 2 times 2. And these guys are attached through multiplication, so I will show you that here. Times y to the third times 2 times z to the fourth times 2. And now you can just simply multiply these terms. 2 times 2 is x to the fourth times 3 times 2 is y to the sixth times 4 times 2 is z to the eighth. Multiple methods to solve these type of problems. Hopefully you found this easy. Math is easy if you take it step by step. Thank you for joining me.